Okay, hi.
Okay, so we've been thinking about various things since the last meeting, and I promised I'd do something about a letter to the Bulletin of Atomic Scientists, which I've done just a summary so far to just summarize the points that I would be making. And then Robert Chris has shown us the results of a chat PT, whatever it is.
GPT.
Yeah, GPT. And I noticed that it's all just text. There's no kind of logic or measurements or anything like that. So it looks authentic. So it's quite dangerous in that sense. People might use it as if it was authoritative. It does quote various viewpoints pretty accurately, but because of the absence of logic and measurements, I think it's rather dangerous. What I did notice, however, was that it showed that there's a confusion about tipping points. Lots of scientists, IPCC, saying we're trying to avoid tipping points. And we can avoid tipping points if we keep below 1.5 C or 2 C degrees centigrade. And what actually are they meaning by tipping points? Because tipping points aren't really points at all. They're processes which involve positive feedback and therefore non-linear, generally accelerating. And that means that they are highly dangerous if they can contribute to sea level rise or climate change, or just global temperature rise, or destruction of the Amazon rainforest. So I think that needs to be made absolutely clear in the letter. I think David Spratt probably does quite a good job on tipping points. I think he does in his article to the bulletin. So I think that's promising. Now, one or two people have said that they're happy to sign the letter. I thought of it as a letter from Prague, but it would be very nice to have a decently long list of signatories from our group and from other groups, if that's possible. So I do want to produce something which is punchy, but not doesn't contain anything which we don't agree, or most of us. But there may be one or two who object to various things, but shouldn't overrule the majority. Okay. Excuse me. So in the invitation to the meeting, I mentioned very short, three short messages which we could give to anybody who was asking about what we were doing and why. So the climate crisis is extremely serious, and that's probably not recognized just how serious it is with the tipping points. What we want to do, the goal we should be aiming for is climate restoration, because that's what we want. We want the legacy, our legacy, to be a world in which the climate and ecosystems are in a better state than they are at the moment, which is an admission that we're moving away from a good place. And the third thing is that we do have solutions, so we can be optimistic, providing we accept the two first premises, the danger, and anyhow, I'll stop there and open the discussion, which I hope we'll find new ways of communication, new people we can communicate with, rather than just analyzing the situation yet again, because we've done a lot of that, and analyzing psychology and so on. I think we need to understand the people we're talking to as individuals and research them. And so I ought to do some more research on the Bulletin of Atomic Scientists to see what kind of papers they've already accepted. It's not one of them is one of those papers was quite strongly against geoengineering, I noticed. So I need to have addressed that in the letter. So over to others.
John, what do you mean by saying that I'm just going back to your 3 simple messages, and you say that essentially apolitical, and I just find that an unusual use of the term apolitical, because to me they're intensely and totally political. Like I think, yeah, just teasing out the meaning of the term apolitical is quite helpful.
Okay, yes, I realize that was a bit of a controversial word to use. Perhaps I shouldn't have used that, but what I meant was that that these 3 messages you could put to people of completely different political views, or on the spectrum, if you like.
Yeah, I agree, and I think that's a reasonable use of the term apolitical, in the sense that it means open to bipartisan support across the political spectrum. But yeah, like given that there are strong vested interests with opposition to that message, and I think that the other meaning of apolitical is entirely evidence-based, rather than grounded in an ideological perspective. And I think that's another interesting area of debate. Like many people would say that your or my perspective is ideological, and like I imagine that that you like I take the view that if you can base your arguments in facts, then that's distinct from a political ideology, which is where it's like there's an element of ideology there in terms of valuing the the survival of humanity on the Earth. And to say that that's an intrinsically good thing is an ideological stance. But beyond that, it's a question of, well, how do we actually achieve that value? So yeah, I find that's just an area I find of interest.
Okay, so I think you can generalize that there are certain a group, for want of a better term, of people who continue to deny that climate change. So Trump said it was a hoax. I'm not sure. He probably changed his mind, and he often contradicted himself. That was his kind of starting position. And then you get others who deny that it's serious in our kind of lifetime. So they're always talking about the danger at the end of the century, if they're middle-aged or elderly. If they're young, it has the terrible effect of, they're leaving it for me. I shall be alive then. And, they're leaving us this terrible legacy. So it's no wonder that Greta Thunberg and people of her age are aghast at what's happening and want action. What they don't know, of course, is that they're not being told what effective action actually would be, which requires intervention. But it's quite a hurdle to get people to realize or face up to the fact that this climate change is already dangerous. It's going to get very much worse, and it's getting worse faster, and that kind of thing. And it's the analysis that Daniel did on 4 degrees was quite instructive, because you could see just how damaging it was if we kind of let things go and don't intervene. In fact, 4 degrees is quite on the cards if we don't do any intervention.
I've got
Paul?
make a comment about the type of message to whom, political, apolitical, or otherwise, the factual evidence does not really change people's minds. It's the emotional understanding that they associate with the factual evidence or some other event in their lives and things like that. To take a purely scientific point of view without advocating strongly I don't think is going to make the answer. So, I mean, is there a politics of a planetary restoration and climate, the climate crisis? If it let the cards fall where they may, which political parties, plural, are on which side? I mean, this is not bipartisan, this is multi-partisan and across different countries and different systems. So my interests have been more on the line of how do we get people to get excited about it? And the facts don't change their minds. It's I see it all the time. I'm very disappointed in it. Had a conversation with a very respected and friend of mine, and I was just sort of had to constrain myself from being very objecting to his position. Well, it didn't really matter much. So the So that's a comment sort of where I stand. I turn off my picture every once in a while here because it's my lunchtime, but otherwise I'm here.
Okay, Paul. Yeah, okay, Daniel.
Sorry. Yeah, it's interesting. You said about obviously the facts don't change people's minds, but it depends where they live and what their circumstances, I think, because you mentioned my analysis, and it was after seeing the video, which basically said that India would be basically completely uninhabitable, so would most of Africa. And my point was that video said actually Canada would be doing really well, and North bit of America and New Zealand would be flourishing, and so I think, even though it did mention there'd be billions of refugees, I think that there are a sizable amount of people who think if they live in those places that were supposedly going to do comfortably at 4 degrees, oh well, we grow lots of lush vegetation, we'd have the ammunition and the military strength to keep out those invading people, and too bad for them. Whereas if you were from India and you saw that, it would probably terrify you much more. And the people who people from areas which wondering how their groundwater sources are going to survive the next decade, let alone till 2050. If they're in those regions, actually, the ex-environment minister from Iran was saying that Iran's probably going to be uninhabitable within 30 years due to the water shortages that will basically cause it to dry up. And so I think if you're from a place that there are a sizable number of papers out there saying you're going to be okay, your agriculture is going to be okay in a couple, in a few decades time, at the same time as those papers say there's some places will be uninhabitable, then you're really you're going to not be bothered by those facts in the same way as someone, unless you're compassionate, that sort of thing. Then I think that's the key thing. That there are some, I think, misleading papers that give this false sense of security to certain regions when we have these worst case scenarios.
One thing that arises for me about this 4 degree analysis, Daniel, is the theme of comparing the planet to a person. So just saying, planetary homeostasis is like the homeostasis of an organism. And really, a 4 degree fever is deadly for a human being. And it's not about saying, well, the surrounding temperature is 20 degrees, and I quite like that, and I even like 24 degrees more. It's my internal temperature is 37 degrees, and should my internal temperature go up to 41, then I would be dead. and so that's I think that's one way of pitching that and even a 1 degree fever will put you in bed. So essentially the planet is currently in bed with aspirin. And we're headed for a quite steadily stronger responses than aspirin. But Robert, Chris.
Yeah, I'm just interested in what Daniel was saying about Iran, because as some of you know, I just come back last week from a month in Dubai, and I've been there many times because my son lives there, has done for the last 10 years. And I won't go into length of my views about Dubai, but it is quite a remarkable place. When you see what they've built there, it is extraordinary in this strip of desert. And one of the things that's extraordinary is the absolutely lush gardens and the complete disregard for any kind of water economy. I mean, you turn the taps on and the water floods out, and nobody is in the slightest bit concerned about water consumption. It just is not an issue. And you see these massive high-rise buildings, and right on the top, plenty of water. Water is not a problem. Now, the reason that is kind of odd is because one of the things that my wife and I did, we visited a museum whilst we were there on this occasion, a new museum. Everything is always being renewed out there. And they had a photograph of a man in Dubai, or just in that region, collecting water by digging a hole under a tree and collecting the water that pooled under the tree. And the explanation was that they had to take the first water because if they then dug a second hole in the same tree, it would fill with salt water. So every time they wanted more water, they had to go and find another tree and dig another hole. Now, what's remarkable about this is that photograph was taken in 1962. 1962. And you just have to roll forward. It's not, what is it, 50, 60 years. And the change is just extraordinary. And where does all this water come from now? It comes from desalination. And of course, if you're not worried about burning fossil fuels, scaling up desalination to provide as much water as you want, provided you have access to the coast and to seawater, ain't a problem. So there's no, I mean, and Iran has got lots of oil. So my guess is that they are going to have no problem finding as much water as they need when the time comes. And it's very difficult. I think we need to be, the final comment is that we need to be really, really careful about prognostications, about predicting how these things are going to unfold in the future, because there is just a huge amount of uncertainty and very path dependence about how these things unfold. And things can change very dramatically, very quickly, both positively and negatively.
Yes, Daniel, you wanted to make an immediate response, and then Rebecca.
Yeah, I mean, I did water management as my specialist option when I was doing my MSc. We had a lot of talks from people at Thames Water and that sort of thing. And we actually came across there is a desalination plant in the UK, which is only used in emergencies. I think they'd only used it once at the time I was doing my course in 2012. But the reason being is that it's 10 times more expensive for them to use it than other forms of water purification. And obviously that's, you know, it's by the, I can't remember exactly where it is. It's somewhere on the Thames, I think, or near the Thames. But it's basically using reverse osmosis, which, I mean, I don't know if they're using it for desalination or if it just purifies the Thames water from the, you know, the bugs and things. But it's a very expensive, yeah, in terms of energy intensity, and also it needs to be situated where, you know, if you've got a landlocked country, for instance, there's going to be a lot of energy in the pumping, and that's another issue. The pumping water from one region to another. It's quite expensive. Yeah, but, you know, if you've got lots of oil,
if you've got lots of oil, that ain't a problem. You know, Israel does the same thing. You know, this is not an issue for them.
But they're all coastal. You know, they're quite small.
Iran is coastal. You were talking about Iran. Iran is coastal.
But I suppose it's inland areas that they're concerned about.
They can take it in tankers. Yeah, I mean, you know.
And that's all fine when it comes to water for industrial and you know, household use, but it's not competitive for agricultural water supply. So
you're quite wrong. You're quite wrong. In Dubai, as again example, they've got huge areas under greenhouse, under glass, which is irrigated. You know, I mean, if you've got the money and you've got the land and you've got access to seawater and you've got access to oil, you ain't got a problem.
I suppose that's for high value crops like flowers and
well, they grow green vegetables out there, all sorts.
Yeah, Rebecca.
I wanted to say, and Chris, I don't like writing this sort of thing in an email because it sounds negative, but I really don't think that there's anywhere on the planet that's going to be all right in 4 degrees. I haven't actually looked at your video, Daniel, but if you think about Canada, they have wildfires at the moment, and it may be moister up there, but I just think that we're heading for catastrophe. And even if, like, Canada would be all right, or New Zealand, we already have queues of refugees lined up at our borders, and so does England, and they're now getting ready to send them down to Rwanda. So it is a planet that we're living in.
Well, no man is an island, as John Donne said. Paul.
Just to pick up on that, Rebecca. I mean, I wasn't suggesting that 4 degrees was okay and that people would be all right with that. I was merely just responding to the specific detail about water management in Iran and the likelihood.
I know. I was talking about some of the things that you put on the email about adapting and so forth. Like, it's going to be every person for themselves and decimation, and it's not any kind of future that I think is going to be okay for any of our descendants.
No, I agree with that. I totally agree. Have I said anything to the contrary?
But I think the politics are that's the implication of the Trumpian mindset, that we can create a gated community, that walls can be our salvation, and it's like it's just scientifically quite absurd, and yet it's the direct implication, and it also involves saying, for example, that sea level rise is not real, and the scientists have been wrong in the past, so they'll continue to be wrong in the future. Paul, you wanted to comment?
You're muted. You're muted. Paul, you're muted. Paul, you're muted.
Okay. The two points. The first one is we're not going to reach 4 degrees centigrade increase while there is still any society around like what we've got now. I mean, the economic systems that will take, which will collapse. I mean, the monetary systems, the global, I don't even know the standard currency of the dollar, when that goes and it becomes the from China or from some other country, euros, etc., that will basically disrupt so much that the next round of depression is within the 30-40 years type, with crises on food and everything else, plus the prospects of war. I think the world is going to be in such terrible shape from these other reasons, and they're not going to be unable to then do the types of actions which are necessary in order to try to save it climatically, with much even less unity in it and everybody in it to do it, for themselves attitude. So that's the one point that comes into it. Yes, we could get to 4 degrees, we get to 5, 6, and upwards. And the one of the two Roberts had talked about the world population dropping down to 2.6 billion or something, and very possibly. The other point is I wanted to discuss about how we societies are not utilizing our full arsenal of efforts. And I did a little write-up about it, and I shared it with 3 of the people who are on this group, and they uniformly came back with saying, yeah, sort of, but it didn't really excite me and didn't get it going. So, all right, I'm not going to read it out. It's too long and everything. But the basic point is, you don't go to war with only your army. You've got to have your Navy. You've got to have your Air Force. You're going to be dealing with the cryptology people and the space stuff and all that as it comes in. And we have, back in World War, in the 1800s, there was no Air Force, okay? World War I came in, and then we got it in with World War II. It's big time. You won't do it without it now. We are expecting to fight the climate crisis without the third branch of the climate forces, which would be the albedo reduction. It isn't even on the cards. I mean, that's the parallel I was trying to make. My writing was too verbose on it or something, but if that message can come out, the analogy may help people carry the understand the message. This is where our problem is, and it becomes a real crisis. It's going to come down to where some country says, yes, I can launch a rocket ship and put aerosols up into the stratosphere and do a whole bunch of things unilaterally, and the heck with everybody else on the in the line. That's a very unfortunate step. None of us will be alive when that's going to be taken, but that when push comes to shove and there's nothing else on it, they don't care. Somebody's going to put it up there. So thanks a lot.
Thanks, Paul. Rebecca?
Yes, I'm just wanting to make sure in our time together, we have time for the whole agenda, which I'm sorry that I missed the very beginning of the meeting, but I really would like to hear an update from Stephen about Marine Cloud Brightening if there's enough time at some point. I'm not sure what our action point is on what we're discussing, but I just wanted to flag that. Because I think if we don't have action, then we may as well, there's no point talking about how we're going to convince people if we haven't got something we can actually do.
Okay, the context of what we're talking about is that John Nissen proposed a letter to the Bulletin of Atomic Scientists, and he raised 3 points to discuss in that letter, and suggested, and one of the themes was the politics of that, and so we've essentially been talking through the politics. But I think it's so nice to see you, Stephen, on the call. And how about we hear from Daniel and perhaps round out this discussion. John Nissen may wish to respond on some of the points that have been raised. But let's hear from Daniel.
Actually, I mean, Stephen's here. You can probably answer this. And it's basically, I wanted to have a response to some of the points that came up in the video that Suzanne shared with us the last couple of days, which is, she said it's the latest, that it rounds up the summary of the where things are on the debate on geoengineering. And a key thing that came up in it is the termination shock argument. And I was just thinking, do we have a strong response to that? I'm thinking in terms of either if the Arctic is being cooled by some sort of geoengineering, then you build up ice mass, and then if you suddenly stopped it, the ice isn't going to suddenly melt, that sort of thing. Or what are good arguments?
I think the real argument again about the termination shock debate, Daniel, is that we are moving into a situation where regulation of the planetary atmosphere will be a permanent requirement, and just that global security and stability requires the mitigation of climate change through technological management of the planetary climate. And so marine cloud brightening, stratospheric aerosol injection, like whatever combination of technologies proves necessary, they're essentially security requirements for the planetary future. And so like the argument that was raised recently, I can't remember who raised it, was that a diabetic gets termination shock if they stop using insulin, but that's not used as an argument not to put them on insulin in the first place. So it's really quite an absurd argument. But just can I just say how much I enjoyed reading Neil Stephenson's book Termination Shock, which wasn't so much about termination shock, but it's a superb discussion of many of the political issues around geoengineering. So Yeah, there was something else I was going to say earlier, but I'd be interested to just check in with John Nissen before we go to Stephen.
Yeah. So terminations shock, yes, absolutely. On our temperature trend analysis, we reckoned that it would be 50 years before we got the greenhouse, could possibly get the greenhouse gases down to 380 CO2 equivalent. So that's kind of halving methane and bringing down
50 years, very optimistic. I would say 100 years.
Yeah, but I mean, that's going to be the timescale for our SRM, you know, and phasing it out. And of course, if Paul's right and we have all these disruptions of economies collapsing and all that lot, it'll be very difficult to keep it going. That's why we want to deal with the most difficult things, most urgent things first. Cooling, refreezing the Arctic, and get this lot going while the world is in a state that it can do it. Otherwise, you've got a kind of deadly feedback that the situation for acting is getting worse as the urgency for action gets greater, which is a kind of vicious cycle.
John, if I could just chip in, I remembered what I was going to say before in response to what I really liked about Paul's military analogy is that we often hear the comment in analysis of military history that generals fight each war with the weapons of the last war. And I think that that's a useful analogy for what's happening in climate politics, because what we're seeing is this idea of if only we can mobilize a popular front and take over the power of the state and defeat the evil fossil fuel powers by decarbonizing the world, then it's like I see that IPCC concept of, you know, a complete decarbonization of the world economy as essentially on the model of a communist revolution. You know, it's like, I know that they're not a communist revolution, but it's still got a whole lot of that psychology. And I just think that we need to find new thinking that's much more about cooperating between different parts of the political spectrum rather than this polarized mentality. So anyway, it's I do think that, you know, looking at the climate situation against military analogies is quite helpful, and so I liked that in like Paul did. He sent me and Rebecca and others his commentary. But yeah, I'll just leave it at that, and can I hand over to Stephen Salter for as Rebecca requested, just some update on what you've been working on. Stephen, is that okay?
Can you hear me all right?
Yes.
Good. Well, I've been working on Marine Cloud Brightening. I'd argue that the advantages of it are that you have regional and seasonal control. You can move them around to suit whatever your climate project should be, and we can now get very, very good real-time information about almost everything that's going on in the atmosphere, and we can put that into different possible spraying strategies and pick the one that suits us best, and we can implement it very quickly, and if we've got it wrong, we can stop it very quickly. We'll just wait until the next rain shower. I've been having a discussion with John Nissen about whether or not it could do the Arctic, and I've pointed out a number of misunderstandings of things like the cloud fraction over the Arctic. And I'm sure that we would be able to save the Arctic. And I agree that that's a very important thing to do. We can do it quite quickly if we're well operating up there, but we can still do it even if we don't go anywhere near it, because heat moves towards the cold places and we can intercept heat anywhere in the world, and that will cool the poles. The position at the moment is that the design I have for it, it uses a vessel with a number of sockets into which you can plug different kinds of equipment. So you drop them in and you rotate them 45 degrees, and this makes all the electrical connections. And so you can have this equipment built anywhere in the world, bring the plug-in units into the sockets and twist them in. If they're not working, you can untwist them and take them out and put a different one in. So it's like the backplane of a 1960s computer. Nobody poked around inside the backplane with an oscilloscope to try and find out what was wrong. They just ripped the card out and put a different one in. It also means that the production time is very short. If you start getting factories in China or India to produce the contents of these things, you can build thousands of them in a year, and we only need perhaps several hundred. So we got a rapid response. I've got 2D drawings of the whole system, all the vessel and the things that you plug into it. And I'm just finishing off the very last one now. And I've been working on the tooling to make the different bits that we need, like the Flettner rotors and so on. And what I need now is to have arguments and discussions with engineers who are much younger than me, who have learned how to draw without seeing a pencil. And I want to have the 2D drawings converted into 3D solid models, which will allow me to pick up some mistakes and do much more accurate weight estimates and much more accurate stress analysis. The trouble is that I have to pay suitably young people. It's incredibly difficult for people who learn to draw on paper with a set square and T-square to convert to the solid modeling methods, that they're completely different. And there's such an enormous negative transfer. I thought it was just me, but if I talk to colleagues of a similar age, and they all agree that they really can't manage to do this because they've been trained to think in a completely different way. So I do need some money to do that. I also need some space. Edinburgh University has a very strong carbon reduction project going on. There's a lavish new building and 40 people working away. And these really hate what I'm trying to do. They think I'm a threat to their grants. And I've been slung out of my office and slung out of my workshop, and I have to find new space. Fortunately, the project we did a long time ago, the wave energy, led to some useful patents, which have led to a small spin-off company which got taken over by a much bigger one. The bigger one is now too big for the space that they've been using, and they're having to move out, and I'm hoping to buy it. And I'm having to find a way of raising about £3 million. I actually have that from my life savings, and we will know whether we got the space for rebuilding my workshop in the end of this month. And I have now a startup company called Ocean Cooling Technology Limited, and we might be having a few shares put on the market. So if anyone wants to attract investors into ocean cooling, this might be a good time to do it. I have been round and round and round all the different parts of it, trying to correct trying to see what I think the mistakes are, and redesigning them and correcting them. And now it's getting much harder to see what isn't going to work properly, or what's too heavy, or what's clumsy, or what might get corroded. And so it's nearly the end of the design process, at least in 2 dimensions. I'll be showing all this to Robert Tulip when he comes to Edinburgh next month. and maybe you can spot some mistakes. I hope you won't find too many, but I'll have lots and lots of drawings to show you. As far as water supply is concerned, a long time ago I did a project on desalination from using energy from waves. So even if oil is not available, we could get energy from waves. It uses a method which is called vapor compression. It's not reverse osmosis, but the energy consumption is about the same, about 4 kilowatt hours per cubic meter. And I hope that will be useful for small islands. I can send anyone a paper who wants to. The quite detailed drawings of it, and it's all the energy is coming just from the action of waves, so it should be attractive for small islands. There is another project which again could help with the water thing, which is to try and increase the rate of evaporation of the sea by punching through the layer of very humid air at the very surface of the sea. And you can do this with a wind turbine like the egg beta Duras turbine. If you have the blades of this long enough to dip into the water and have them hollow, the water will be centrifuged out along the blade. And if you then squirt it out through the trailing edge of the blade, you recover quite a lot of the kinetic energy that's got by the velocity. You need to be able to adjust the...
To help with that, try searching in the Apple Watch app on your phone.
Someone's interrupting me. I don't know if they're hostile to wave energy. Anyway, you can then squirt it out and recover a lot of the kinetic energy. And this will give you 2 or 3 cubic meters of water a second as a fine spray. And you can do it just far enough off land that the salt residues fall back in the sea, but the water vapor can come ashore. And you don't know which country it's going to end up in, but if you do enough of them, maybe it'll be equal fair shares. I hope that would be interesting to some people. As far as the termination shock is concerned, if you stop electricity, you get major problems in a few seconds. If you stop water purification, it's a few days. If you stop the internet, it's again probably 20 minutes or something. So the termination shock isn't an excuse for not doing things. So you just have to be more careful about making them reliable. If we did lose all our spray vessels, the heat goes back in about 10 years. That's what the models say. But we should certainly be able to rebuild a fleet of them within that time. And they're very widely dispersed. So you can knock out a few of them, but you won't be able to knock out all of them. And it's very easy to see where they are and where anything attacking them is. So I think the chances of them collapsing are much less than the problems of bad nuclear breakdown, where you can't put things back together and quickly, or you can't rebuild them fast enough. So I hope that's useful. Are there any questions?
Look, it's very useful, Stephen. I think that what's distressing is this fundraising problem that you're facing, and what it illustrates is the difficulty of telling a story that is compelling to a general audience. And so the situation that we face is that the technological vision that you've presented is it's quite simple for those of us who take the interest in it, and yet, as you're saying, you find this extraordinary political hostility from the whole decarbonisation movement. And so we have this political movement that sees such a strong sense of despair about the climate situation and so has clutched onto this idea that if we only decarbonize the economy, then we can find hope. And they see your work as just completely undermining that whole political ideology, and so they say, you must be, shut down and ignored and opposed. And so I'm very much looking forward to catching up in Edinburgh. I'll be there by the end of this month, which I'm looking forward to, and then catching up with others in Cambridge in early June. So thanks very much. Now there's lots I'd like to talk to about water, but I won't. I'll hand over to Robert Chris.
Yeah, Steve, just one very quick question, hopefully a quick answer. How are you doing with regard to the nozzle design and the work that's being done at Cambridge or elsewhere as well?
Okay. Well, what we've done is the nozzle design is due to my colleague Tom Stevenson, and the problem is that you want to have a very, very small nozzle. It's got to be smaller than the drop size, and you can make this by etching big holes. When I say big, I mean about 50 microns through a silicon wafer, but stopping when you get to an oxide film. All right, so you can etch through and then stop. So you've got a 50 micron hole going through about 0.7 of a millimeter. And then on the other side of the oxide layer, you have another layer of silicon, and you can etch much smaller holes through this, and stopping again at the silicon oxide layer. And then you can put an etch in, and you can dissolve away the silicon oxide layer. So you've got a whole lot of tiny, tiny holes going through a very thin bit of silicon, and then meeting a much bigger hole, 50 microns, going through the rest of it. And we've built a computer climate model, sorry, a computer simulation model using a software called COMSOL physics, COMSOL multiphysics, which is suitable for this sort of experiment. And we've pumped water through the model, as it were, and we can tell you what the size of the drops is going to be for different nozzles, and what the pressure is, and how fast they come up. They're using what's called Rayleigh jet breakup, and everybody agrees that this is the most efficient way to generate the spray. You need a pressure of 80 bar to pump through those size nozzles, and that means that it's the vessels that I want to make would be about 300 kilowatts. But everybody who's in the inkjet industry, absolutely all of them, completely emphatic that this will never work because of the clogging of the nozzles. They've had a miserable time. The whole of their career has been blocking the nozzles of jet printers. And if you talk to people who work in the reverse osmosis industry, they say, oh, yeah, sure, we can do that. We're already doing it in thousands of cubic kilometers a day to clean up the water before it goes through our reverse osmosis nozzles. Okay, but reverse osmosis is exactly the same, but only much, much smaller, because you're trying to stop the salt particles getting through. And they say they will promise that they will guarantee them for 5 years, and they expect them to last for 10 years. Okay, so that means we can filter the water really very well. But what I've got is an arrangement where I can have a hatch that closes the wafer head, so that birds can't make messes in it and the waves can't break into it. So I can shut it off. And because I can shut it off, I can pump water from the other side, the outside, back through the nozzles. And I've also got, I need to do this anyway, because I can't let salt dry out in them, and I can't let ice freeze in them. So I've got to be able to get them completely cleaned off, even we can put a vacuum there to dry it out very quickly. So I've got a very nice way to backflush the nozzles, as well as backflushing the filters that I'm cleaning the water with. And then immediately close to the wafer, I've got an ultrasonic cleaning piezoelectric thing, which can put spikes of negative pressure onto the nozzle. So I can have +7 bar on what would be the outside of the nozzle and -7 bar 40 kilohertz on the inside of it, which means that I can clean up the nozzles at any time that I choose to do so. And
Stephen, Hugh Hunt commented at the NOAC meeting that that the technological challenges could prove insurmountable. How are you getting on with Cambridge and technical support there?
the only information I've had from them was what was on the web, which I was able to play a recording of. And he was saying he was having a terrible time measuring the size of the drops. Okay, and the reason that is you can't measure the size of the drops because of what the work done by Kohler. And once a drop has come out of a nozzle, the size of it doesn't depend on anything except the weight of the salt in it and the local humidity. If you look at the Kohler curves, you can see that the dimension of what you spray will depend entirely on the local relative humidity. It'll either grow because the humidity is high and stuff's condensing on it, or it'll shrink because it's getting into a lower humidity. So he shouldn't be measuring liquid drops. And I've sent him, I sent him and whoever was on the circulation list of the talk he was given, a way to do this by spraying into very, very dry air and getting dry crystals and measuring them. Okay, and he ought to have thought about that. I hope he's understood it. And I'm now doing a quick design of a lab experiment with lay flat polythene bags, which I can pump water through a deep freeze to get all the water out of it. So sorry, air into a deep freeze to get all the water out of it, then re-warming it and then putting it into the bags. And then
Stephen,
pumping
let's just go back to Robert. Chris, did you have a?
Yeah, I just wanted to ask him. You're talking all about the theory here and the design, but in terms of actually a prototype or a physical thing that demonstrates that these ideas are, if not yet working, at least making progress.
Well,
is there something tangible, something that you can pick up and look at, say, oh, that was good, or yeah, I can improve that. Right.
We have etched little chips, silicon chips, with the double etching with the two sides.
Well, who's the we? Who's the we?
Well, Edinburgh University has some friends of mine, Camille Lunari and Andreas Siames, who did the COMSOL multiphysics. So we etched these things. They're little 10mm square chip. You can't see anything from the small nozzle side. If you look at it from the 50 micron side, you can see sort of dark gray patch. And if you put a magnifying glass on it, you can just see the 50 microns. Now, we used a technology using contact printing, which is very cheap to do, but not as good as the most chips being made now. And we could do much better with optical imaging rather than contact printing. But with contact printing, we could get to double the size that we need. And so we're really confident that we could do it with optical imaging. And I actually taken chips to Cambridge to show them. I showed them to Sir David King. You may remember that, John Nissen may remember that. We had a meeting with David King in Cambridge, and I showed him these chips. And I was hoping to get some water pumped through them, salt water pumped through them to make some spray. But when I was thrown out of my office from Edinburgh University, I had one box in which all my most precious possessions were, and the box was stolen and the chips have gone missing. So that has been delayed. But
I would desperately want to move things on because it's now 10 o'clock, got half an hour left, and we haven't talked about our strategy and how we're going to communicate get our message across. Our message is going to be SRM, combination of stratospheric aerosol and marine cloud brightening and others like cloud removal.
John, could I?
That's what I'm going to be saying to the Bulletin of Atomic Societies. I want just signatures on that, please, and I'll try and get the letter completed within the next week. And so that's one body we can talk to. Last time we mentioned the possibility of talking to the military. If anybody's got contacts or thought any more about contacting the military since the last meeting, I'd be very grateful to know. Now, Doug, I think, has been attempting various lines of attack. Is that right, Doug?
Well, I've got a couple of questions for Stephen with regard to messaging and also fundraising.
Okay,
just
Doug,
order of magnitude.
Let's just go in order. So Rebecca wanted to speak, but
I think I was next. I was next.
Okay, go.
Yes,
yeah.
I'd like Doug to go first because he hasn't spoken yet.
Good. You go, Doug.
So with regard to messaging and fundraising, order of magnitude, I read something in one of your papers like $3 million or 3 million pounds. Is that for the several hundred or is that each?
No, that is for doing the basic research for the testing out the hardware.
Okay, research. So order of magnitude, are you?
The most, I think we might be ready to start building vessels if we've spent about 20 million. Okay.
Okay. So I just want to get an order of magnitude. What does one of these vessels, and you've mentioned corvettes and things, which I don't know anything about. What does one vessel cost roughly? $1 million or $100,000?
Okay, right. Well, I better tell you how we worked it out. If somebody reveals the actual true manufacturing cost of a product, they lose their job. Okay, so it's very difficult to get things precise. What you have to do is to look around for something that's made in similar numbers, that is working with the same sort of power, that's got the same sort of working environment, and perhaps the same level of complexity. And the first thing that I did was the number of ships we built during 1940. The corvettes were used.
So Stephen, I've heard all this. I want to move this along. I just want to know roughly, is it $1 million per vessel?
I would
roughly
say
100,000?
I would say it would be $4 million for each vessel in mass production.
Okay.
And
so then my next question is how many would you need? You said several hundred. Is that just for the Arctic or is that for the entire world?
For the entire world, if they were all working at full power, you'd need about 400 of them. Now,
worldwide?
For the whole world.
Okay, you don't need to go any further. Don't go any further.
You need
so we
about
now have
you need about 100 for just the Arctic. Now, they won't always be in the right place, so I think you'd want to have 800 of them for the whole world.
So, Doug, what's
800?
your next question? Yeah.
So I'm trying to get to the total. How much are we going to ask for? So to do a test, you're going to need 1 or 2 or 10 in a container on some island someplace. What would that cost? 100,000 a piece?
Yeah, my estimate for that over several years of observations is, I think, £5 million
per each,
right,
per one?
No, the whole experiment.
The whole experiment. Okay. So
building
Rebecca,
the equipment and running
Yeah.
it and getting the data analyzed.
Okay. So we know how much it would cost to test and to ramp up and to what level. Then the next question is kind of go, no go. Would that 800 vessels be able to reduce the temperature of the Earth as per John's chart?
Yes.
Okay, that's all I want to know.
And so that's about $3 billion. And so $3 billion is small change. And my sense is that in terms of John Nissen's question, how extraordinary that George Soros sang Stephen's praises to the Munich Security Conference, and yet here we have Stephen getting kicked out of his office. Like, who is following up with Soros to say, what was that just performative? Is it something that's a serious question?
Well, Robbie, can I say this is where I would. Oh, sorry, Stephen.
No, so Rebecca, you speak.
I'm not sure, Stephen, you must get lots of emails, but I've been working with Doug on trying to write up your practical proposal to get funding. And rather than spread it far and wide when it becomes a kind of work of, loses its focus, I'm wondering if I could forward that to Robbie, because what I'm trying to do is say, like, Soros, we know Soros has got deep pockets, but what exactly would he be funding, or anyone else for that matter? So I'm wondering, like, you may not have seen it, but could I forward that over to Robbie, because it needs some technical work, but I'm trying to place it. Oh, thank you, Stephen. I don't know, Doug could say a bit more about what we were trying to answer, but the sort of things were the science of what we're trying to do, the cooling power of it, trying to place it in the Marine Cloud Brightening literature about gated tests, so that when we have something, we're relating it back to what the literature is, because there's quite a lot of critique. But basically say, here's a proposal. I only put 2 million in it, but basically this is what we need and this is what we think the effects will be.
Yes. The thing that worries me is what I call the half-sucked lollipop effect. I'd rather have no money at all than not enough to do it properly. Okay.
Well, I know you said that, and we should ask for what we want. Like Soros has got his checkbook open, but he needs someone to go and say, here is the actual proposal that you can spend your dollars on, hard-earned or not hard-earned. It's not the point.
What I'd like to do would be to have a series of stages where if we can get through one stage successfully, we are sure that the next stage funding will be there. Okay, so if I can make a tiny little nozzle and get the right size of salt crystals, then I get the next 5 million. And if I do that, then I'll get the next 30 million. All right. So at the moment, I don't have any civil servants breathing down my neck and screaming about deadlines and everything. And this might seem to be an ideal golden age compared with what might happen when people have put a lot of money in and need to see the results very quickly and don't give us enough time to do it right. I will certainly help in any way I can with your proposals. I did once try to get George Soros to help me with a way for clearing anti-personnel mines, which he was interested in, and I didn't get any money that way. And I'm not optimistic that he'll send anything to Edinburgh. I think he's probably much more likely to send it to Cambridge, but we'll have to see about that.
Let's talk about it with David King and others. I'm looking forward to following these up. John Nissen?
Yes. We should try and contact George Soros and David King and see how we can progress this, because what George Soros says is what we've been saying. The situation is extremely risky as a global security threat, and it requires refreezing the Arctic, and we need to pull out all our stops to refreeze the Arctic. He's got our message. Lacking one thing, which is that's all necessary on the path to producing a better planet for future generations, for our descendants, as Rebecca put it. I am optimistic on one front. I think that people who've got the kind of power to make things happen in the US and so on are extremely concerned about the rise in weather extremes. And if we can argue from the science that this can be reversed, by cooling intervention, whereas it will continue to get ever worse without cooling intervention. I think that's an argument that could hold sway in very high places.
Well, I can send you the calculations for moderating hurricanes and reversing sea level. And both of those look as if they're achievable. I think I've sent them to quite a lot of people. I'm not sure if everybody has got them, but if you haven't got them, I can send them.
Thanks, Stephen. Daniel?
Yeah, I just wanted to clarify one simple way of summing up how Marine Cloud Brightening could help. I'm actually working on a draft script for a video that would be about this sort of thing. But one of the ways that Stephen described it is that if 10% of the world's surface was brightened by 6%, that would basically do the trick. And that would be, is this right, Stephen? Just around, I mean, rounding up a bit, saying 15% of the ocean, if the cloud over 15% of the ocean was brightened by 6%.
I think it's a bit less than 15% of the ocean.
14% actually, but just being something like 14.2.
Yeah.
Is that right?
Yes, so we've got 0.6 watts per square meter too much at the moment, and we've got the cloud fraction. Well, low cloud fraction is 18%, so you can work it out from that.
Look, I'm feeling quite optimistic about all of this. I was able to speak to an audience of 500 people at the federal parliament yesterday, but it was just for the 35th birthday of Parliament House. But I do think that there's a range of audiences that we have, such as George Soros and David King. Also, my friend Eric in the Australian Climate Authority. Yeah, sorry, I was going to make another point, but I'll just leave it at that. Yeah. Okay. So
well done, Robert. Do you think they got a message?
No, I wasn't talking about. I only talked indirectly about climate, but it was just brief. I'll tell you about.
I've regretted bitterly sometimes not raising the issue of cooling intervention. I had a chance when I was standing in front of the Environment Audit Committee alongside Peter Wadhams, and one of the MPs, who shall be nameless, said geoengineering is moronic. There was a deathly silence. The chairwoman, to her credit, said that that's out of order. But anyhow, I was so nervous, I deferred to Peter Wadhams, and he said, we have to reduce our CO2 emissions. And I regret that. I've regretted that ever since, because that was my one chance. Never have a chance like that again, I suspect.
The trouble that worries me is that there's 40 times more CO2 in the oceans than in the atmosphere. And the balance between the atmosphere and the oceans depends on the vapor pressures of CO2. And if you are able to reduce atmospheric concentrations, some of the CO2 in the oceans will come back out into the atmosphere. So
we know that, Stephen. That's common knowledge.
Yeah,
equilibrium.
That means that that even if you could do something which is clearly moment from the Keeling curve completely impossible, it isn't going to be enough, because we'll be stuck. I've got a couple of papers which show that
CO2 removal is not going to work, and Peter Wadhams was just saying the things that he probably had to say as an academic. And I was in a position of not being an academic. I could have spoken out, and I really regret I didn't, because that was a chance to and then get recorded, because it's all these meetings are recorded by people, shorthand typists.
John, what I was going to say was that where I'm coming from this conversation is that I think that the next steps are to I appreciate Rebecca's path towards a business case for investment in marine cloud brightening, and I think that that's a really constructive focus, and I'd like to I suppose find people who can help with that business case work, and I'm particularly thinking of Achim Hoffman as somebody who's offered to use his experience working with venture capital to help refine the business case, because really the sort of path that I see is working through Sean Fitzgerald to present something to David King, to present to George Soros, and just getting the story out there that's about essentially why somebody should buy Stephen's company, if that's a reasonable way of putting it, and basically put $20 million into Stephen's company, so that it's then while Stephen is still with us over the next a decade or two, we hope,
I'm 84.
Right.
I'm 84. You can't rely on that.
Yeah, sorry, I'm being super optimistic there, Stephen. Our planet's fragile, our personal lives are very fragile, so we really need to move quickly. Rebecca.
So I would like to take the topic off this, except to say that, thanks, Robbie, I feel there's momentum there, and I think if we work up our framing, we can then get it, review, input, critique, with the goal being to get a funding proposal before a venture capitalist or someone with a large checkbook. What I would now like to say is a couple of comments from my scientific reading and podcast listening about carbon dioxide removal, and also baseload or continuous energy generation, mainly to say that I think the future might be more optimistic than what we are allowing for on current technologies. And this is work from Caltech. One of them is a test that is, I think, almost at scale and ready to go for carbon dioxide removal in the shallow oceans, and then storing the carbon in wells, disused oil or gas wells. Another one is having microfilms in space outside of the sun and moon shadows. That one is very early, but that would provide 24/7 power. And they've done calculations even on the amount of loss between getting it from outer space down to Earth, and it's comparable with the loss from coal generation, that sort of thing. And another one is geothermal, which has been on Dave Paulus's channel, where they're now getting ready to, there's a prototype for geothermal that's being built, I think, in Europe. So all of these things are in not the last one about the geothermal, but the other two are in some transcripts from the science show that I sent around to a few people a week or two ago. My main point is that we will need cooling. I'm convinced of that on my primary school understanding of the climate math. However, there is a lot happening in the CDR and renewable energy space that also gives hope. And so I'm trying to kind of paint a picture of all three of them. Humans have got the chance to pull ourselves out of it, and there are technologies on the brink.
Thanks, Rebecca. So we've got 9 minutes till the half hour, and I'd like to conclude the call there. So I'd just appreciate just going around the room and getting people's final comments of the last 10 minutes. Who wants to speak?
I really wanted this meeting to focus on communication and getting how do we get our basic message across about the need to refreeze the Arctic as the top priority.
Yeah, so I think your suggestion of writing to the Bulletin of Atomic Scientists is an excellent one, and so I think are you going to expand the outline that you've written into a draft letter?
Yeah, and I would like to get people's signatures on something which is not too anodyne. I think when HPAC does these documents, they try and cover far too many points, and then they have a lot of arguments about the detailed wordings. I do have offers of help from Tom Gorrow, because he's very keen on to support us and also to get coral reefs onto the radar, the plight of coral reefs. So I think if we could get them as a kind of scientific authority on board, I think we could also perhaps do some visible attacking on things like the AGU. AGU produced a thing on which they claim to be a viewpoint on the ethics.
Yes, the ethical framework, yeah.
Ethical framework, and I consider it unethical. I think that's quite a good title for a paper, kind of startling people a bit. I don't know where we publish that, but that would be a good.
I followed up on your comments there in an email that I circulated. It's like it's absolutely right that to say that emission reduction must remain the primary focus is just ignores vast quantities of evidence, which is unethical for a scientific body.
Yeah, and it's unethical not to be aiming for a better climate for future generations. We owe it to try and clear up the mess we've made. And I think that has to be very important aim, and perhaps that's where we start when we try to persuade people what we want to do, rather than starting by frightening them to hell, which tends to turn people off. I don't think frightening people persuades them. They momentarily might agree with you, but when they walk away, they want to forget it, and they do forget it.
I see lots of stuff about frightening people, which doesn't say that if we increase the albedo that we can do something about it. And I say, well, what's the point of these things about saying how terrible things are if you haven't got any solution?
Well, Robbie, I think they don't say that because A, they don't know there is a solution, and B, even if they think there might possibly be one, it's not practical and ready to go, and C, they have not evaluated the benefit cost, the benefits of doing the tests and possibly deploying the technology compared with the risk. So, but the main point is most people don't have any idea that what the problem is and that there is a solution. And that's why I like our communications that we're trying to do. But I think that's been evidenced in the last couple of talks that I've been to when you've spoken to the general public, that most people haven't got the first idea, A, of the problem and B, of the solution.
Yeah, exactly.
Yeah, people are being very misinformed, dangerously misinformed by IPCC and the authorities, and the idea that emissions reduction is the solution to climate change is such a wrong message. I mean, it is extraordinarily dangerous.
Is emission reduction a moral hazard, a threat to the other sides that we've got? It's the opposite way that they argue it. So we just put that.
No, we should not buy into that. That's divisive, and the technologies are underway to reduce emissions and to extract carbon. We really do not need to make it into an either or negative critique of the other side, inverted commas, because
You're
it's
right.
actually happening. The technology transition is underway, but we need cooling to solve our problem, even with everything that's already underway.
It's our immediate problem, which is one of increasing risk. So we can't say that the Greenland ice sheet is going to collapse tomorrow, but there is a finite probability that it does. You know, and if you multiply that by the effect of the Greenland ice sheet collapsing, that's an existential for civilization. So it actually works out as a very high risk. And
do we have a statement or examples of marine cloud brightening? And I seem to remember that Robert Tulip had a statement that they were trying something up at the Great Barrier Reef or something like that. Where do we have any evidence of this has been done so far? And we, as much as I like Stephen's design of the boat that gets its energy from the wave action and everything else, put a sprayer on a regular boat and make a cloud that can be seen from space. I mean,
I'll send you a photograph of one that was done by Discovery Channel in about 2007, a place called Liaplek off South Africa.
You sent that. I've seen that one. Yes, very good. We need more.
Right. Well,
yeah,
I have two other shots of it. I've got maybe Discovery Channel would release the picture. They made a lot of other mistakes in that program, so I'm not real that keen to have it all re-shown, but maybe we could edit the highlights.
Thanks,
So
Stephen.
really,
We'll just go to a final comment from John Nissen.
Yes, I just wanted to redress the balance because everybody's talking about marine cloud brightening. Stratospheric aerosol injection is hugely promising and it's scalable. And I haven't yet had any convincing arguments against it. You could say it's so powerful that it could be used daily. To any technology. So I think that's an argument against it.
Yeah, well, I'd like
so thank you everybody for coming, and I hopefully will make some continue to make progress in getting our central messages across, both to the scientific community and politicians who can act on it.
Very good. I think it's been a very good call. Thank you very much, and I'll circulate the recording.
Thank you.
Thank you,
Robert.
Okay. Bye-bye.
Bye.
Okay, bye.